Thank you, Jean-Louis, and thank you all for your kind invitation to present this report. This report is actually has been performed by the 3 working groups of IPCC, so it is really a sort of a cross-disciplinary, interdisciplinary report. The first message is about really how does climate change affect food security. And from the scientific literature, we could see that in many lower latitude regions, yields of some crops, like maize and wheat, have already declined because of climate change, while in contrast, in high latitude regions, yields of some crops, like sugar beet, have increased over recent decades, partly because of global warming. Climate change has reduced animal growth rates and productivity in some of the pastoral systems in Africa, and there is also robust evidence to show that agricultural pests and diseases have responded to climate change, resulting actually in contrasting patterns, increases and decreases of infestations. For the future, most of the literature shows that the stability of food supply is projected to decrease as the magnitude and frequency of extreme weather events increases, since those events are disrupting the food chains. We can also say that increased atmospheric CO2 levels will reduce the nutritional quality of crops in terms of the micronutrients contents. And this may have implications also for food security, like zinc and iron contents. The economic models project actually a rather large variability in terms of increase in food prices, but the median of the economic models is 7% increase in prices due to climate change by 2050. And obviously the most vulnerable people will be more severely affected. We can also say that increased warming in some regions may amplify migration both within countries and across borders. So in summary, I think this graph shows you on a color scale where you can read out the risk levels, where we stand now, where we have currently with the current 0.85 degrees Celsius warming, infrequent price spikes that affect individual countries. For a 1.5 degrees Celsius, we may get periodic food shocks across regions. And already at about 2 degrees Celsius warming, we enter in a very high probability of severe impacts or risks for the stability of food supply chains with sustained food supply disruptions globally. And I must say that in the 5th assessment report, we were saying that it was at around 4 degrees Celsius warming that there would be severe risks for global food security. So I think this report, which is more recent, 2019 report, is actually more alarming because it does show from the literature that there can be sustained food supply disruptions globally, even at moderate levels of warming. On the other side, we know that food systems contribute to emissions, and when we define food systems by incorporating all the inputs, all the productions in farms, and the transportation plus the transformation in agri-food systems and so the use by consumers. I know this is cross-sector, but it brings us to large values of emissions from that global food system in the range of 21 to 37% of total net anthropogenic greenhouse gas emissions. The response options, however, across the entire food system, from production to consumption, including food losses and waste, can be deployed and scaled up to support adaptation and mitigation. There are indeed a number of agricultural response options, and I'll go back to this, that can deliver co-benefits across the land challenges. And we can see that the total mitigation potential from crop and livestock activities and agroforestry is estimated with a strong potential between 2.3 and 9.6 gigaton of CO2 equivalent per year by 2050. So I think what is specific to this report is that it covered not only climate change and food security, but also interlinked challenges. And I'd just like to show you on these global maps how these challenges overlay. On the first map here on the top left, you have the land use types. In ecology, they are sometimes coined anthromes. So croplands, rangelands, semi-natural forests, villages, dense settlements, wild forests and sparse trees, but also barren land, like deserts. Well, on top of this, we can see how the pressures or the challenges for the land systems overlay. Here is the climate change adaptation, where we use the similarity in seasonal cycles between end of century and current to show where we get very high challenges in purple. Here you have the desertification from land use. Note that there is also desertification from climate change, but we here specify it from land use. Here is a land degradation using a soil erosion proxy. So you already see that in some regions, say like in South Asia, you have an overlay of climate change adaptation with large challenges and land degradation. But further, these regions are also exposed to food insecurity in the sense that there is chronic undernourishment. There are also, in some cases, biodiversity hotspots that are threatened, and some of those regions are equally exposed to groundwater stress from the over-abstraction of water. And here again, if you look at India, they are also exposed to excess nitrogen and phosphorus loads that degrade the water quality. So as you can see, it is not only climate change that is affecting those land-based systems, they are also exposed to other stressors. So what we have done is look systematically at the potential global contribution of response options to those challenges, mitigation and adaptation to climate change, combating desertification and land degradation, and enhancing food security. So I'd just like to explain first how we proceed. We look at the positive or negative impacts, and we do this with mitigation, looking at the gigaton of CO2 that could be mitigated, abated, for adaptations in millions of people, and the same for food security, and for desertification and land degradation, it's in millions of kilometers square. So as an example, you can see here that increased soil organic carbon content has actually large positive impacts on all those dimensions. So it is a response that could create co-benefits delivering to all the challenges at a cost which is shown as a medium cost. Here, compiling tables from the SPM, but also from Chapter 6, we extend this view to the biodiversity and to the groundwater stress and water quality impacts of those responses. How do they create co-benefits, or how do they create trade-offs? So here again, if we look at increased soil organic carbon content, there are positive impacts on all dimensions, so co-benefits. In contrast, if you look at some of the possible responses, if they are deployed at large scale, like bioenergy and carbon capture and storage, you have some negative impacts on some dimensions, creating possible trade-offs. This is because if you deploy on a large scale those bioenergy crops, you would have some negative impacts on food security, but also on biodiversity and on other challenges. It may be of interest in the context of this meeting to look specifically at the livestock management, at the grazing land management, and if we do improve on those two practices, we get co-benefits across many of the challenges, possibly not large co-benefits, however, for the groundwater stress and the water quality. As you can see here from those maps, we can say that those regions in the world, and I was referring when presenting the individual challenges to some parts of South Asia, but it's also true for Africa, they are exposed to a large number of challenges, actually to up to 6 land-based challenges. And on average, these are countries where the Human Development Index is lower. So we can say that the greater the number of land challenges, the lower on average the Human Development Index. This is significant across countries. And also those countries that are exposed to more challenges are unfortunately also having less responses delivering co-benefits to all challenges. So in a nutshell, if you are in a situation where you have a lot of land challenges, there are fewer responses delivering only co-benefits, and usually you are in a poor country in those circumstances. So we've been looking into the area-based potential deployment of land management responses with only co-benefits or with some trade-offs for the local challenges. So if we stick to some of the agricultural responses, we can see for improving grazing land management, improving livestock management, there are co-benefits on large areas. There are only weak effects, so no harm responses for part of the area for the grazing land and the livestock. And you can see here again that some responses like fire management, increased soil organic carbon content, are actually creating co-benefits on all the area, that is for those land use types. And here again you can see that other responses like bioenergy and BCCS would have the potential to create negative trade-offs. So when we go back to some of the key challenges like desertification and land degradation, we can say that fighting against those challenges has immediate and also long-term co-benefits for adaptation and mitigation. Many activities to combat desertification can contribute to climate change adaptation, reduce biodiversity loss, and have positive impacts on sustainable development. And if we can reverse the desertification, we can improve soil fertility, increase carbon storage in soils and biomass, while promoting agricultural productivity and food security. So this is really a part of what I would call the nature-based solutions. It's really how you can get co-benefits by applying those options on a large scale. However, the large-scale deployment of mitigation options such as bioenergy and afforestation would have negative impacts on food security, biodiversity, and land degradation. But let's say that this depends on the scenario. If you are in a scenario where you have high population, there is a high pressure on land for food security, for food supply, and therefore even for a moderate scale of deployment of those bioenergy options between 0.1 and 1 million of kilometers square, integrated assessment models find negative impacts for food security. If you look then at a low population scenario with strong environmental policies, there is more scope for using those responses, and they could be used between 1 and 4 millions of kilometers square without creating negative impacts on food security. This report has also looked into the value chain and risk management response options, and you can see here the demand side options like dietary change, reducing the food waste, reducing the post-harvest losses, so they have mostly positive impacts, so co-benefits. You can also look into sustainable sourcing, improve food processing, retailing, improve energy use. This has weaker effects actually on mitigation. So going back to the food, we know that food losses and waste contribute to 8–10% of anthropogenic greenhouse gas emissions, so this is quite substantial. 25 to 30% of food production is lost or wasted, and therefore a reduction of losses and waste could release millions of kilometers square of land by 2050 for other options. About the diets, we note that the diversification of diets and therefore of production systems could support climate change adaptation and mitigation. And you see that there are many options, including resilient and low-emission livestock that could be used. And by 2050, food transition towards healthy diets could release millions of kilometers square of land with co-benefits for environment and health, and bring an emission reduction, which is quite uncertain because it is in the range of 0.7 and 8 gigaton of CO2 equivalent. If we take even a broader view on the different socioeconomic pathways and how they affect the levels of risks that are related to climate, we contrast here the SSP1, where we would have 8.5 billion people in 2050, and the SSP3, where we would have 10 billion of people. And we see that the risk level for desertification, land degradation, food insecurity is obviously larger in that socioeconomic pathway where we have a high population density. We are also in a world where we have more inequalities and where we have less environmental policies. And now we should have a quick look at how land use could be affected by those socioeconomic pathways. And we see that actually in all the integrated assessment model for SSP1, also for this middle-of-the-road SSP2, and for another socio-economic pathway about resource-intensive production and consumption patterns, we see that all models project a reduction in the area of pastures. Some project a reduction in the area of croplands, but this reduction is actually more pronounced in the sustainability-focused world than the other scenarios. And you can see that there is a large increase in contrast with the bioenergy crops in purple, and so we can understand that there would be conversion from pastures to bioenergy crops. So I think it is important to be able to discuss those integrated assessment models, the way they represent the livestock sector in the future, and how it reconnects to mitigation, adaptation, and to the other challenges. Finally, I would like to end by a message of urgency. If we were to delay climate change mitigation and adaptation measures, we would have increasingly negative effects on land, and this would reduce the prospects for sustainable development. Late action in all sectors can reduce the potential of all the options and could have irreversible impacts on some ecosystems. In contrast, rapid action on climate change mitigation adaptation, aligned with sustainable land management and sustainable development, has the potential to reduce the risk to millions of people from climate extreme, desertification, land degradation, and climate change, also food insecurity and livelihoods. So postponing greenhouse gas emission reductions from all sectors leads to ever greater economic impacts for many countries in many parts of the world. So thank you.
Thank you very much for that interesting and clear report. I just have a particular query about the reduction in pastures that's proposed in some of the pathways there. And just wondering, are you only considering pasture as a ruminant feedstock? Or are you looking at it in terms of other potential opportunities that are increasingly being looked at now in terms of, say, biorefinery approaches, for example?
Yeah, thank you. I think that the way the integrated assessment models look at those land use change is that if the herbage is used for biorefinery processes, then it would be coined bioenergy crop, even if it's actually based on a semi-natural pasture. I think they are not yet able to make a distinction here. So I think it's rather the way the material is used, so it would not go to the livestock, but it would go to bio-industrial processes. Then it would be seen as bioenergy crops or something, bioenergy land use at least.
Jarmo Juga from Finland, University of Helsinki. Thank you very much for your presentation. Just one curiosity question. You showed the conclusions about healthy diets and the savings in land use and emission reductions. How did you actually define the healthy diet there? And was there only one single healthy diet or alternative diets? Or why don't you just speak about plant-based diets rather than healthy diets? It's always a bit confusing that people make these kind of choices and definitions with only one single option there.
No, this report is actually looking into the World Health Organization recommendations, guidelines, and they do, let's say, recommend some levels of, say, animal proteins, which are typically lower than the average level of animal proteins in many of the OECD countries, but are significantly higher than the current levels of animal proteins intake in some parts of Africa, of South Asia, where we know that these levels are actually extremely low and can contribute to malnutrition. So I think the report is using those guidelines. You will find in Chapter 5 some further discussion based on the literature on which types of diets are, let's say, leading to which levels of greenhouse gas emissions, but this was already shown. I think we got a slide about such literature, and there are other references also in Chapter 5.